In this video, I'm just going to talk a little bit about polynomials. So polynomials are a function that are written in this form. So it looks a little complicated, but really the a's are just coefficients. These are supposed to represent just numbers, okay? Any real number, and the x's are variable. And we have exponents, which are supposed to be positive integers, okay? So, and almost, I don't want to say every function that we've looked at has been a polynomial, but many of the functions that we've looked at, y equals 5, that's our constant function. Y equals 2x plus 3 is a polynomial. Y equals 3x squared plus 1 is a polynomial. And these are the more simpler ones, and as the degree increases, and when I say degree, I mean the greatest power of x is our degree. And as the degree increases, analyzing the polynomial becomes a little bit more complicated. So let's just look at some examples here. I have g of x and h of x. And the first one, g of x, this has a degree of 5. Okay, that's called a quintic, not that you need to know that. H of x has a degree of 6. Notice what you're doing is you're finding the variable with the greatest exponent. So this has a degree of 6. Okay, now there are some basic characteristics or features of polynomials that you should be familiar with. Okay, the first is that a polynomial, a graph of a polynomial, has to be continuous. Okay, and what I mean by continuous is that there are no breaks, no holes, no gaps. So it would look, something like this. This would be a continuous polynomial. Something that has a break in it, like something like that. This is not a polynomial. Something that just has a hole. So if it looked like this, okay, this has a hole right here, that would not be considered a polynomial either. Polynomials have rounded curves, so you could see this right here when I drew this. This has rounded curves. So something that does not have rounded curves, such as the absolute value function, that is not a polynomial. Let's see, what do we got here? Let's look at even and odd functions, okay? So these are really even and odd powers, I should say. Not even and odd functions. So power that is even. So let's say you have a polynomial function and it has a degree of 7. Okay, so odd powers, this would be an odd degree. Let's specify that even more, an odd degree. So this polynomial is going to go like this. Okay, it's going to start down, bottom left of the graph. It's going to do some stuff in here, and then it's going to end up going up in the end. So when I mean some stuff, I mean, depending on the degree, you could have many bumps and curves in there. The higher the degree, the more bumps, or turning points you're going to have in there. If the degree is small, say it was x cubed, right? Looks something along those lines. Okay, so the end behavior here, if we look at as x increases, So as x goes to infinity, your y values, your f of x values, also go to infinity. That's looking to the right. Okay, that would be your right end behavior. As you're going to the left, as you're looking to the left of the graph, your y values are going down. So f of x is going to negative infinity. So this changes as the degree changes. So what we just looked at here was for odd polynomials. Okay, if the degree was even, so let's just say x to the fourth, and remember it's only the greatest power that matters. So if we're looking at something like this, okay, even though your coefficients are odd, right? We got 3s and 1, and your powers, 2 of them are odd. We got 3 and 1. The degree is the greatest exponent, so your degree is 4. So when we have an even degree, your function is going to look something along these lines. And what happens in the middle, again, changes depending on how great that power is. So if that was x to the 14th instead of to the 4, we might have a different looking function in here, but your end behavior is going to be the same. So just like I did for the other one, if we look to the right as x is increasing, so as x is going to infinity, your y values are increasing here. So your y values are also going to infinity. As we look to the left, so that's going to negative infinity. As x goes to negative infinity, our y values are again increasing. So our y values, f of x, is going to infinity. Okay, so knowing the degree of the polynomial helps us determine the end behavior, which can be very helpful when it comes to graphing polynomials and describing some of those characteristics. Okay, there's a lot more characteristics I could get into, but those are going to be the main focus of this section. The one thing that we did not go over is the zeros of a polynomial, which I will talk about in a few